All right, let's continue the build. Just taking all the screws out of this piece right here. I'm going to go ahead and install these into the boom. And all you got to do is just line it up exactly with the holes. And get these mashed in here. This piece right here and this piece right here goes just like that. So these are flanged bearings. They have one side that has a lip on it. It goes like that. That'll be on the outside. Let's go ahead and make sure that this has got plenty of Loctite. Before we get any further, I want to take this apart and make sure that it's Loctited, which I'm sure it isn't. Crazy part about this one is it's a 1.5 millimeter, but the thing that you will like is it's not a solid feathering shaft all the way through. I'll show you what I mean. So we have our thrust bearing down in there, but this block right here has a shaft on each side of it, and so you don't have a solid feathering shaft in the back because there's a hole here that you need to have. So it's got two of them, which means that if you just hold this for each side, you can tighten it down without having to have two Allen keys at the same time. So again, just like the big rotor, here's the bearing race. You can tell because it's got an indentation into it. You have one washer and you have your bolt. And then you have your thrust bearing with, again, the open side of the bearings facing the inside, not the out. And then you have another washer. So that's, or I'm sorry, another bearing race. So it's exactly like the top one. We're not going to mess with it much. I'm not going to take it out of here. But what I am going to do is the same thing that I did with some of the other things on this heli. I'm going to get Loctite on my wrench, and I'm going to put it down into this hole. And again, there's a very specific reason for me doing this, because it's super easy to accidentally get Loctite into your thrust bearings. And if you do that, it defeats the whole point of having a bearing. It turns it into not being a bearing. So let's get this back on here. Let's go ahead and reinstall this. This goes right onto here like this. So we need to take these out one at a time, Loctite them, put them back in. So now we gotta say working collective tail. So the way that this one works is we just need to screw this into there. All right, that's on there. Need to take this out right here. All I did was put this shaft through everything. I take out that grub screw, and you can see there's a flat spot right there. Need to just put that through to where you can see it. Load this thing with Loctite. Forgot to put my flanged bearing in there. It was right here. Like that. This one's got a nice huge divot that you can see. Clean this up. Alright, so you just push this all the way over. Install your flanged bearing. Put your vertical support on here. Line up these holes. Let's get a screw with some Loctite. Let's move on to the next thing. Let's go ahead and get this bolted onto the tail so that we can kind of measure out the rod that goes to the back here. Actually, you need to get your belt around it. Just like that. You can leave it hanging wherever you want. So, let me get this 420 out of the way. What I'm going to do right now is I'm going to go ahead and equip my belt. I actually have one of these push rods from a 420. So this is a 380, so it's going to be significantly shorter. But I can take this and I can zip tie my belt on here. And then hopefully feed it through. I mean, I could have used a twisty tie, but I don't feel like going out in the kitchen and getting one. And then let's cut that zip tie. We can pull our push rod out. Could have used a hanger, whatever you want to use. Whatever's at your disposal. So, in knowing that the main rotor goes clockwise and the tail rotor goes counterclockwise, when you put your belt on, all you do is spin the main rotor and see if they're going in the correct direction. The belt is on the correct sides of the belt tensioner here. And the belt tensioner here, it should be on the inside. And so now we're going to spin the main rotor clockwise. So clockwise. And what are we spinning here? Counterclockwise. So if it's going this way, that would be incorrect. And basically all that you would have to do is take this belt off and flip it over and put it back on. So clockwise. Makes that one go counterclockwise. The way that you adjust the tightness on these is loosen all four of these bolts back here. And then I push on this part of the fiberglass and you pull this whole assembly backwards. That's why these are on here like this. These 4 bolts. Because this whole assembly slides back and forth. So you want to pull it as far back as you can. And I mean, you want to do it fairly hard. It's going to hurt your fingers a little bit. Up here. Main thing is you just want to make sure that that this belt tensioner here still has some spring left. If you have some spring left here, then that means it can it can loosen up and loosen your belt a little bit if it needs to be. So, but that's feeling pretty good right there. So now we're gonna make the push rod, which, to be honest, when I very first made one of these, it's super weird and it seems generic and it seems like it's not gonna work at all. It does work. I mean, you can get it apart, but you definitely risk cracking or shattering the fiberglass tube. Let's put on the plastic ends. So we just put a little bit of CA on there and then jam this thing in here. And you want it to go all the way up to the bolt itself. Because I have activator, this makes stuff instantly set when it's a CA based item. So I'm gonna just put a little bit around this. Like so. And then I'm going to activate it and just get that frozen there. I'm going to do the same thing on this side. Just a little bit of CA all the way around it. Hit it with the activator to freeze it immediately. The activator does evaporate fairly quickly, but it feels greasy for a little while, and then within half a minute it's all evaporated. So it will dry out your skin pretty good though if you spray it on yourself. Let's continue on. I'm going to go ahead and get this snapped onto the servo. I'm just going to hold it in place while I grab the pliers. Alright, so we got it snapped on the servo. So I'm going to actually use my ball link pliers and get it on there that way. So now that's there, and we have a functioning tail rotor. Now we can start looking at the ESC, see how we're going to route it. In my opinion, the best place for it is right here. And then the ESC lead I actually run up through here. Alright, that's number one. Alright, that's tightened down. So you can see I run my ESC wire lead back here. So you see it a little bit here, not too bad. Make sure if you're going to run it in this tray that it stays down. It needs to be clear of the battery that goes in and out. So you can see it down in there. It's perfectly flat. I kept the cable exactly flat, so there's no twists in it or anything like that. And then personally, from here, I run it up through here and route it the same way that I did the tail servo. So I'm going to pull this bolt out and route it through. the ESC wire coming out here, it's flat against the chassis, and then it comes up right here to plug into our flight controller. We can install our flight controller and satellite. All right, well, my servos were kind of binding up, which doesn't surprise me. I pulled all the servo horns off, and in order to do that on this, you literally have to dismount 2 of the cyclic servos. I have my Wi-Fi device plugged in for my Spirit unit. It's called a Wi-Fi link. It goes into the system port and then into an auxiliary. And I got my radio up, which is it's responding to commands. So it's already linked. I had already bound the satellite receiver months ago to my TX16. So I need to figure out what the IP address is, because that thing, the wireless link for Spirit is kind of cool because it just creates a web interface that you can connect to from any device, just at 192.168.1 whatever. And you can also pair it to your app on your phone. Now we're going to pop our servo horns on here. Now that our servos are centered out, we just again want to make sure that they're at a 90-degree angle. All right, let's power it back on. I'll grab my swash leveler. All right. So basically what I'm doing is in the Spirit software, when you check mark this sub trim box, it sets your swash plate to what it considers to be completely flat. So when it says that it's flat, obviously it doesn't mean that it's flat. So you check mark this, it sets it at what it thinks is flat, and then you put your swash plate leveler in there, and you move those sliders around until these little notches right here are just barely touching the swash plate itself. And I just keep nudging it until it's perfect, and then when you uncheck mark this box, then the settings are saved. And I'm going to go ahead and come over to backup. This is to update your software under unit. I'm going to go to profile and say save, and that saves it successfully to my flybarless unit. So just to kind of run you through here, when you open the program, this is where it sits at. It'll show connected if you are connected. If you're not connected, you can hit Control W, and that will bring up your Wi-Fi connections, and then you can tell it what IP address that you're at. So mine's on 111. So connected. So under General, you set which way that the unit itself is facing. Mine's facing just like this. The wires are towards the rear. Mine runs CCPM 120. That's the configuration. So Servo 1 from the flight controller would be this one. Servo 2 is this one. Servo 3 is this one. I'm running DSMX. Your diagnostic screen is where you can look at your radio and move channels on your radio, and watch and make sure that everything is going in the correct manner, that nothing's reversed or anything like that. So you come over to your servos. This is where I was doing the sub trim. I did have to reverse these 2 servos and leave these 2 not reversed. in order for my pitches to all be correct. On my other helicopters, it's usually 1, 2, and 3 are reversed and 4 isn't. So, I mean, I guess it can vary. We come over to limits. This is your collective pitch. We'll mess with this in a little bit. But as you raise and lower this, you're going to get more pitch. So if you are starting at like 18 degrees positive and like 19 degrees negative, that's way too much. So you need to lower this down to where you're at like, you know, 13, 13. So cyclic ring I don't mess with. Rudder endpoints we'll do here in just a second. My sensors are at 60%. My rudder gain I mess with in the transmitter so that I can, so like this right here, that is a panic switch for me. If I was completely upside down and messed up, if I hold this, it will automatically make the helicopter come right side up and be perfectly level. So honestly, you get yourself into trouble quicker than you can pull that switch. But stabby is what mode that you're in. So I put this on stabilization normal, which means that you have bank limits, you can't roll over, etc., etc. But then in my transmitter, I tell the gyro not to have anything on. And then I set this switch to bring my gyro back. So my gyro here is set to positive 50 on this trimmer pot. When I pull this, it sets the gyro to negative 50. And that engages all of my safety features. So auto leveling, bank angle, limiting, etc., etc. And then under advanced, we don't mess with a whole lot here. And then we're back to the backup screen. So the next thing that I want to get on is my rudder endpoints.